Hello everyone. So today we'll be seeing about implementation of k-means clustering for customer segmentation using machine learning. So I'll be explaining the program line by line. Starting with the first line, import pandas as PD. Here we have imported the pandas library as PD. So this library is commonly used for data manipulation and analysis. And then we are reading the CSV file. So we have created the CSV file and the name of the CSV file is null customers.csv. So we are just reading the CSV file using uh, pd.read CSV function, and then we are displaying the first few rows using data.head function, and the next line data.info function, which is it is used for checking the data information, and then the next line data.isNull.sum of. So this function basically this expression calculates the total number of missing values, that is the null values in each column of the data frame, and then we are importing k-means from the library sklearn.cluster, and then we are creating an empty array which is WCSS. So basically we are creating a k-means model here. So we have initiated a k-means model with n clusters, and the parameter we are setting it to I, and the I is ranging from 1 to 10, and the initialization method we are calling it as k-means plus plus. Okay, and then the fit method is used to train the model on the features of the data frame starting from the fourth column. That's what we are mentioning in the data.ilog function. We are mentioning the fourth column. And then the inertia of each value of I is stored in the WCSS list, the list which we have already created, an empty list we have created, right? So the I value is calculated and stored in the empty list named as WCSS, and then we are plotting the elbow curve. So the code here, it plots the elbow curve by plotting the inertia, which is WCSS, against the number of clusters, and the range is from 1 to 11. So the x-axis here represents the number of clusters, and the y-axis here represents the WCSS, and the elbow point on the curve, it actually indicates the optimal number of clusters. Okay, and then the next step is that we are setting the number of clusters. Okay, so we have chosen 5 clusters, that is n clusters equal to 5, and we are choosing it based on the elbow method. Okay, so the k-means model is trained against 5 clusters, so that's what we are giving in this code, that is km.fit of data.ilog of. That's what we are mentioning it here, and the predicted cluster labels for each data point are stored in ypred. Okay, that is y underscore pred. And then we have created a new column named cluster in the data frame data, and we are assigning the predicted cluster labels ypred to it. Okay, so we have filtered the data to create new data frame, that is df0, containing only the rows where the cluster column has value of 0. Okay, so here we are giving df0 is equal to data of inside the double quotation we are giving cluster equal to 0. Okay, so what this code actually does is that it creates a new data frame, okay, df0, which contains only the rows where the cluster column has the value as 0, and similarly we are creating df1 where the cluster value has cluster column has the value as 1, and similarly we are creating df2, df3 and df4, and then at the same time you are plotting that with different colors for each cluster. Okay, so here the x-axis is annual income and the y-axis is spending scope. Fine, and then the line that plt.scatter of df0, what it actually does is that it creates a scatter plot for cluster 0. Okay, and then this points, that is the scatter plot, no, they are colored in red color. Okay, and similarly we are scattering the points for df1, df2, df3 and then df4. Okay, and then plt dot legend of function, we are using this function uh, because this line actually adds the legend to the plot, which indicates that the color, uh, this line actually provides color for each cluster. It defines which color is for which cluster. Okay, and then plt dot title of customer segment. So this line tells that the title of the plot, we are setting it to customer segments. Okay, so that's all about the code, and thank you.